Hi students, MCQ number 36. Two spherical conductors A and B of radii 1 mm and 2 mm are separated by distance of 5 cm and are uniformly charged. If the spheres are connected by a conducting wire, then in equilibrium condition, the ratio of the magnitudes of the electric fields at the surface of the spheres A and B is to be determined. Now here the radius of the first and the second spheres values are given, distance of separation is given. These informations are not required actually because these two are connected by a conducting wire. Now initially the charge present in the first sphere is Q1 and the second sphere is Q2. Now when they are connected by a conducting wire, they will attain an equilibrium such that the potential at every point on the surface of the first sphere will be equal to the potential at every point on the second sphere. This is the condition given here. They are connected by a conducting wire, so that V1 is equal to V2. So 1 by 4 pi epsilon naught into Q1 by R1 is equal to 1 by 4 pi epsilon naught into Q2 by R2. Because the potential of the first sphere is equal to the potential of the second sphere. So cancelling these constants, now I can write Q1 by R1 is equal to Q2 by R2. Or Q1 by Q2 is now equal to Q1 by Q2 is equal to R1 by R2. So this is the first equation required here. So what is the electric field at any point on the top surface of the first sphere? Let us say that is E1. So E1 is equal to 1 by 4 pi epsilon naught into Q1 divided by R1 square. So this is the electric field on the first sphere. Similarly, what is the electric field on the outer surface of the second sphere? E2 is equal to 1 by 4 pi epsilon naught into Q2 divided by R2 square. Now the ratio, therefore the ratio of E1 to E2. So this is equal to what? The constants get cancelled, is it not? So this is Q1 by R1 square into R2 square divided by Q2. Therefore E1 by E2 is equal to Q1 by Q2 multiplied by R2 square divided by R1 square. Okay. So instead of Q1 by Q2, what shall be substituted is R1 by R2. Okay. So this is equal to Q1 by Q2. In place of that, I am writing R1 by R2 into R2 square divided by R1 square. Okay. So this R1 and power get cancelled, R2 and this power get cancelled. This is equal to what? R2 divided by R1. So it is given that the radius of the first sphere is 1 mm and that of the second is 2 mm. Therefore, E1 by E2 is equal to R2 by R1. So this is 2 mm divided by 1 mm. So this is equal to 2 by 1. Therefore, the ratio of E1 is to E2 must be equal to 2 is to 1. Okay. So which option is the correct answer? Option C is given as 2 is to 1. Therefore, option C is the correct answer. Okay. I hope you must have understood well. Fine.